shape of the molecule or the element. So we know that if you have talk about these as being electrons, they have to be perfectly spaced apart so that they are equidistant from one another. The closer you bring them, right, the more interaction they have because like charges repel, right?
Yep.
Okay. So, but he was only able to explain the first 20. So therefore, that whole concept of that atom went out the door. And then we introduced Bohr and Rutherford, and we came to the idea that there's these energy shells. Right? And then now we have to add a little bit more to it because the atoms get complicated as you go up the periodic table, and then when we did organic chem, they get even more complicated because the electrons don't always reside in the same lane or electron shell. Right? So the valence shell electron pair repulsion theory is supposed to be able to explain the shape of a molecule. So if you go online and look at a shape of a molecule, they give you this ball and stick model type thing. All right. So for us, we usually deal with things in terms of like what we can draw on a page here. All right. On one of your one of the diagrams I gave you, there's like kind of like what I call a three-dimensional type orientation of structures there, right? I think it's this guy here. Okay? So we know that molecules don't exist on a board. They have an X, Y, and Z orientation, right? So therefore, it's three-dimensional shape. So everything's dependent on this thing called how electrons repel one another. All right. It also deals with a concept called electron pairs and something called lone pairs. All right. So most of you, I think, will understand electron pairs because it's simple. It's very simple. Okay. So if we assume that that's carbon, all right, and we assume that each one of these is H, like so. All right. All right. What type of bond is going to exist between hydrogen and carbon? A covalent bond, right? So I'm going to, just for the sake of, I'm just going to draw it like that. All right. So you have these four things around it. All right. Each one of those things is called an electron pair.
What's the name of
Well, that's the nucleus.
All right. So that's electron pair. So in other words, we could go and draw this like. All right. So simple, very organic chem. All right. So each one of those represents a bond. All right. So a covalent bond with equal sharing, right? And we call that an electron pair, right? Which works okay for carbon because that means the shell is full. All right. And the reason it's full is that you have 1, 2, 3, 4, 5, 6, 7, 8. Right? Every electron, outside electron that is in carbon is shared with something else. So therefore, there's nothing that exists by itself. Correct?
Yeah.
Okay. Everybody okay with that? Mm-hmm. All right. Well, what happens if you go and change that and say, let's try. All right, let's go and change it. We'll make this nitrogen. Okay, so if we go back and look at what you know right now, all right, nitrogen has how many outer electrons?
Negative 5.
5, right? Okay, so just keep that in mind. All right, so, but it needs how many electrons to?
3.
Needs 3 more. So it can easily, all right, if that was hydrogen, all right, there would be 1. Okay, there would be 2. All right, and there would be 3. All right, so all I see right now is 1, 2, 3, 4, 5, 6. Where's 7, 8?
Get that double?
Because it's
Where's 7, 8?
They're still around.
Okay, they're floating around.
Well, they're
Okay.
still in the
All right,
same shell.
so they're like that. Okay, so how many electron pairs do you have, and how many lone pairs do you have?
3 electron pairs.
Okay, so you have 3 electron pairs, and you have 1 lone pair. All right. does this lone pair affect the shape of that molecule?
Yes.
Why?
Because it has its own mass.
Hmm?
It has its own mass and it can attract it towards it as well.
What?
I don't know.
Hit him. Hit him with the side of your. Okay. All right. What do these? Okay. What do these electrons? So if I take these electrons out,
I was right.
okay, let me just take those out. What would the shape of that molecule look like?
Triangle.
A triangle. Like that? You sure?
No.
Okay. So you're gonna say
No.
Triangle.
like that?
Yeah.
Okay. If I go and put these
Oh,
guys
they're gonna repel. They're gonna
in
repel.
here, what are they going to do to this shape?
They're gonna repel.
They're going to cause a repulsion somewhere, because that means that they're now going to say, hold on a second, we've got these electron pairs, but these two guys are actually going to push them even further apart, all right, which is going to change the shape a bit more, all right? So now that's where the issue becomes. So right here, it's not an issue, because therefore, if they're all equidistant apart, they're all taken together, which means that the distance from here, here, and here is exactly the same. When we get over here, these two lone pairs here are going to push something apart. What are they going to push?
Electrons. The
Pairs.
electrons.
Which pair?
The hydrogen pairs.
So are they going to? So in other words, are they going to? Whoop. Okay. Stop bouncing. Okay. So in other words, are they going to affect here, here, here?
Wherever they want.
What?
Wherever they want.
Wherever they want. In other words, wherever they're going to be, like
Wherever they are with the bond is
right, wherever those two electrons end up residing. Okay? So if they take up residence here, they're going to affect these two. Alright? Which means that if they push them apart,
They're gonna spread them equal distance
okay?
apart.
So if they push them apart like that, guess what happens here?
He gets moved too.
He gets moved as well.
Straight.
Right?
Yeah. So there's equal distance.
So it's equal distance apart. Alright?
So,
Alright? Everybody kind of understand that whole?
yeah, they're.
Oh, that makes sense.
Alright? So in other words, these two here actually act like what?
Their own pair.
Like their own electron pair. So if you were to say, you probably could go that there's actually a line, like I'm not going to put, well, sorry, a dotted line right there. Alright? So instead of having actually just 3, you actually have 4. Okay? Everybody all right with that so far?
The fourth one is.
Okay, so here's the easiest way for me to try and explain this too. Okay, in your group, I hope I have enough, right? You need to come up and get 5 balloons. Okay? And no, gentlemen, I don't want to hear them being popped, whatever.
I'm right here.
Let's go.